Hello and welcome back to another video where today what I'll be doing is going over plane geometry. Other topics such as hyperbolic, spherical and parabolic geometries will not be discussed in this video, but hopefully will be discussed in future videos to come. I apologise for the squeaking of my chair, it needs oiling. As always, with mathematics we begin with the ancient Greeks, in particular Euclid and his assumptions which he proposed in a book called The Elements in 300 BC. From that he made a lot of logical deductions and essentially created plane geometry, or that's how I understand the history anyway. Please feel free to correct me. So today I would largely like to go through topics around the assumptions, try to explain the assumptions a little bit and why they can possibly be useful, only kind of suggesting the ramifications of what these assumptions could do. Okay, so first things first, I've moved myself into the corner. Hopefully me looking away isn't too distracting. I've got my script and my recording software on my second monitor, so I apologise for that. So the first order of business is Euclid's first assumption. Any 2 points can be connected by a straight line. What I mean by this is you have 2 points, let's say A and B. Let's actually move these a bit more to the centre. And he says that the assumption that we can make is that these 2 points can be connected with a straight line. That's a straight line. In case I didn't say earlier, by the way, the software I'm using is called GeoGebra. Okay, so that's the first assumption. The second assumption is that any straight line segment can be extended indefinitely into a straight line. So this is a line segment. It is of finite length. We don't know the length. We don't deal with lengths per se in detail too much in plane geometry. We can only say if something is of equal length, double the length, and so on. So I can just say, for example, plot, excuse the points there if you can. But you see, if I extend the line this way, just indefinitely, and I extend the line this way, also indefinitely, that we get a straight line. It is of infinite length. Going back to the line segment that we had earlier, this line segment here of A and B, what we can also do is take the assumption that given any line segment, we can draw a circle that has this line segment as its radius and then one of the endpoints at its center. So what I can do is I can make a circle, finishes there. That is now the circle's radius. We can do that in plane geometry. We can assume that we can do that in plane geometry. You can imagine a pair of compasses with the point there and the pencil at the far end. You go zoop, all the way around and you have a circle. A pair of compasses, a pencil and a ruler is essentially all of the mathematical tools that we will need to do plane geometry, and that's what's so marvellous about it. Okay, the next assumption we can say is all right angles are congruent. Congruent just means has the same size. So say here, for example, I can say, if we assume that I'm good at drawing, then I can also say that any rotation of this, so if I do, assuming these have the same length as these, this is also a right angle, just rotated it. If I do a slightly smaller one, that also is of a right angle, which is the same angle as this and this. Finally, and let me make some space for this, what we can do is, okay, so Euclid takes the following assumption, the parallel postulate assumption, that if 2 lines intersect a third, such that the sum of the interior angles on one side is less than 2 right angles, then the 2 lines intersect on that side. So what does that mean? 2 lines intersect a third. So take a line kind of like this. The next thing we want to do is it says that 2 lines intersecting the third. So if we make 2 lines like this, now on the monitor it doesn't look like they intersect, but you can imagine that these continuing off to infinity, you can see that they're getting closer and closer, okay? And that's because these aren't parallel lines. That's the assumption we can make. That's all what the assumptions mean. Go back over really quickly. We can create a line segment between any 2 points. We can extend the line segment indefinitely, okay? We can extend the line indefinitely from either side to create a line. A line segment is finite in length for some length, and a line is of infinite length. Going back to the line segment we had, we can construct a circle whereby this line segment is its radius. This is the length at which you set your compass at, where you move it out, you do your circle thing, and you've got yourself a circle. So the next one is all right angles are congruent, are the same size. I think that's fairly intuitive. And the final one is we can have a line, another line, and another line. As long as these two lines approaching this third line aren't parallel, they'll cross on the other side. And we can see here that they cross here, that they cross here. That's all what the assumptions are saying. So if I'm to bring up my notepad, what I would do is say, number one, any 2 points can be connected by a straight line. So for example, we have our point A and our point B. Go ahead and connect the two. As always, my artistry is perfect. The second is any straight line segment can be extended indefinitely into a straight line. Okay, so that would be taking what we've got before, and all I'm going to do is just put dots there to show it goes off for infinity. 3, given any straight line segment, we can construct a circle with its radius as the line segment and its center as one of the line segment's endpoints. So to draw that, show you what that's like, we can take our point A and we take our point B and we connect them. Then what we can do is create a circle at one of these endpoints. Hopefully you understand what I mean. So B is the endpoint of this line segment. I've chosen B to be circle C. The circle is, it's called C for circle. B has its midpoint. The line segment is the radius of C, and the line segment meets C at point A. That's all I'm saying. Point 4, all right angles are congruent. So I've just put a little arrow to show what congruent means, and it means have the same size. I'm not going to draw a diagram for that. I think that's pretty self-evident. Parallel postulate. 2 lines intersect a third such that, remember that this colon means such that, some continuity from the last, from my first video, such that the sum of the interior angles is less than 2 right angles. And what I mean by this is, i.e. less than 180 degrees. Then the 2 lines intersect on that side. So, to draw this, what we do, we'll go back to full screen. For clarity's sake, assume that these go on infinitely. That's what these dots represent. Remember, this line segment is not a line segment, it is a line because these dots go off on either side, showing that it's going off to infinity. So what we can do is, what the question asks us to do is draw 2 line segments, something like that. It says the sum of the interior angles, so that's, put it clearly, 2 lines, so that's this line and this line, this line and this line, drawn in orange, intersects a third. The third line is this line, such that the sum of the interior angles is less than 2 right angles. Interior angles, I will say, well, that's this and this. And if I take those as my interior angles, it then tells me that if they're less than 2 right angles, then the 2 lines intersect on that side, which it does. If I were to take these as my interior angles, well then these are greater than 90 degrees, so the lines wouldn't intersect on that side. And that's the parallel postulate. Okay, hopefully that was helpful, and that'll be all for today. Thank you. I'd like to also remind you as well to please hit that like button, subscribe button, and hit the bell notification for more. Please become a Patreon on my Patreon account. I could really do with the help. If you like what I'm doing, please tell me. If you don't like what I'm doing, please also tell me. I'd really like to know. I would just like to share good quality maths videos. I've got a couple of recommendations about making the text bigger, editing the videos a little bit so they are a bit more succinct, to show my face, so hopefully that makes it that these videos connect with you more as the viewer, and to possibly add some more visualizations, which is kind of the entire reason why I'm doing plane geometry, because then we get to do cool little diagrams like this. Trust me, there are more cool diagrams to come. However, I would really like to get through this as a kind of tester before I start doing anything computational. You know, things with, say, chaos, with differential equations, partial differential equations, computational partial differential equations, some biological models, complex numbers, differential geometry, which this comes in handy for a little bit. Other than that, to conclude, our postulates are any 2 points can be connected by a straight line. Any straight line segment can be extended indefinitely into a straight line. I'd like to add here my correction. Straight line segment. Any straight line segment can be extended indefinitely into a straight line. That's what we have here. Given any straight line segment, we can construct a circle with its radius as the line segment. That's what this is. And its center as one of the line segment's endpoints. That's what this point B is. All right angles are congruent, i.e. have the same size. Finally, the parallel postulate. If two lines intersect a third, the sum of the interior angles is less than two right angles. If that's the case, then the two lines intersect on that side. Here we have two lines in orange intersecting a third, the line in blue. I've chosen the red parts as the interior angles, and then that demonstrates that the orange lines intersect on the same side as the side with angles less than two right angles. Okay, thank you very much.